Welcome to today's lesson. I am Siamasaka Kirendens. Today, again, we have an interesting lesson. I'm going to take you through organic chemistry, and in particular, we'll look at isomerism as well as how actually we can test a substance, whether it is saturated or unsaturated. That is a hydrocarbon, whether it's saturated or unsaturated. So we go straight into the lesson for today. Well, as I indicated, today we are looking at isomers. Well, actually, isomers are organic compounds with the same molecular formula, but different structural formulas. What it means here is that this organic compound will have actually the same molecular formula, but the arrangement of atoms in this compound will have different arrangements of atoms. So that's what's known as the structure being different. And so actually, there are different structural variations of the same organic compound, but it will have different structural variations. And so because of the differences in the structural variations, so typically these organic compounds have also different physical and chemical properties. Okay, and so we'll here typically look at some of the examples of isomers, and we have here butane with the two isomers, and here it depicts actually where the double bond is. So the molecular formula for butane is actually carbon has 4 atoms and hydrogen has 8 atoms. And so here, if we put the double bond on the first carbon, it can either be this side or this side. Then this one becomes but1 ENE, becomes but1 ENE. And similarly, if we moved the double bond to the second carbon, that it means that, but the molecular formula would be the same. Actually 4 carbon atoms and 8 hydrogen atoms. And so here we have moved actually the double bond from where it was to actually second carbon atom. And therefore it is called but2 ENE. Okay. And so another example of an isomer is propane, propanol, which is an alcohol. It has this formula: 3 carbon atoms, 8 hydrogen atoms, and 1 oxygen atom. And here we have actually positioned the hydroxyl group on carbon number 1. Okay, on carbon number 1. And similarly, if we brought to this side, it will still be on carbon number 1. Okay, and so if we positioned now the hydroxyl group on carbon number 2, it changes its name to propane 2OL. Okay, so this simply means, but if you check, the molecular formula is the same, while the positioning of the hydroxyl group has been changed to carbon number 1 and to carbon number 2. So this shows that actually propanol has actually 2 isomers. Similarly, butanic acid also with the molecular formula carbon with 4 atoms, and the hydrogen with the 8 atoms, and the oxygen with the actually 2 atoms. So here, what makes the structure to be different is the functional group, which is the hydroxyl carboxylic group. The carboxylic group is a functional group for organic acids. And when we situate it in the first carbon atom, then this one will be butane 1-oic acid. And similarly, if we moved this carboxylic group, this functional group, to carbon number 2, and then it becomes butane 2-oic acid. Here we have moved actually functional group, carboxylic group, to carbon number 2. And so I thought we would look at the actually isomerism. And actually what we have seen here is that the same compound, organic compound with the same molecular formula has different structural formulas. And so this is actually what it means to have isomerism. And so now we go ahead and look at how we can determine whether an organic compound is saturated or unsaturated. I've given examples here for 2 of these typical organic compounds, which are hydrocarbons, alkanes, and the alkenes. And as we are aware, alkanes actually are saturated, while alkenes are unsaturated hydrocarbons. And so for us to determine, if say we are given just an organic compound and we do not know whether it is an alkane or an alkene, or it is a saturated or unsaturated organic compound. And so we can test actually using 2 methods. The first one is actually using bromine water, which we can put actually in a test tube containing that organic compound. And then we add orange, red color of bromine water. And if actually the coloration disappears, it means that that organic compound is unsaturated. So if we have here an organic compound inside, we don't know it, and then we have bromine water, which is orange red, and we pour it in this test tube containing an organic compound. And if the coloration actually disappears, meaning that it becomes colorless, it means that organic compound is unsaturated. In our case, we would say it's an alkene, since we are comparing alkanes and alkenes. Then, if the orange-red color of bromine actually persists, it means that organic compound is saturated. What it means is that if here we have an organic compound and we actually add bromine water to this organic compound, and then lastly we have an organic compound plus bromine water, and then the color of actually the orange-red color of bromine remains the same. It means that actually that is a saturated organic compound. And in our case here, we are saying it's an alkane. So this is actually how you can test whether an organic compound is saturated or unsaturated using bromine water test. And so now we look at the second method of determining whether an organic compound is saturated or unsaturated. We can actually typically use alkaline potassium permanganate test. This one as well, in a test tube containing actually an organic compound, you can add it. And if the pink color persists, then it is actually that organic compound is saturated. So in other words, we have our pink potassium permanganate in a test tube, and this organic compound, we add the potassium permanganate. And therefore, in the end, we are going to have the organic compound plus potassium permanganate. And if the color persists, meaning that the color remains the same, pink, it simply means we are dealing with an organic compound which is saturated. In our case, we are saying it is an alkene, since we are comparing alkanes and alkenes. Similarly, if the pink color disappears, then it means that that organic compound is unsaturated. That is, if we have an organic compound and you add potassium permanganate, and therefore at the end you have organic compound plus potassium permanganate in this test tube, and the color, actually the pink color, disappears, it means that that compound is unsaturated, or it means that in our case it's an alkene. And I thought actually today we'll look at these very important properties of isomers, as well as organic compounds, whether they are saturated or unsaturated. I think this is a very important tool that we can use actually to test whether actually the compounds are saturated or unsaturated using potassium permanganate as well as bromine water tests. So I thought this is very important and it's normally asked in the O-level examinations. I hope you take keen interest to study it thoroughly so that it gives you a leeway to pass the examinations. Well, please could you actually subscribe to my YouTube so that you can continue getting these lessons. I thank you.